So is my screen visible to all of you? Is my screen visible?
Yes, sir.
Okay, okay. So let's start with the week 7 discussion of this course, Computer Vision, and this course is taken by Professor Jayanta Mukhopadhyay, Professor Computer Science and Engineering, Department IIT Kharagpur. Myself, I am Paul. I am a PMRF research scholar from IIT Kharagpur, and I am a TA of this course. By TA, my duties are I will solve a few of the questions. Okay, someone is joining. Yeah, I will solve a few questions which are very much similar to your assignments, so that whenever you'll be solving your assignment, it will be very easier to you. Okay, so by this I am starting the session. So in previous class, what we have studied is regarding feature detection, feature description, and feature matching. Okay, in this class we will continue that feature matching part. So feature matching part is nothing but matching key points, right? Matching key points in different two different images. So what is this matching key points? So once we have descriptor from both the images, because matching means we have to like match same or similar type of descriptor in both the images. By that we can match this two corresponding key points. Okay, so once we have descriptor from both the image, what we do, we take a key point descriptor fi from image A, okay, and compare it to all the descriptor gi from image B. So use a how we do it, we use a distance function to measure the similarity or dissimilarity. So how it works, if that distance that we are measuring from fi to gi, fi is key point descriptor in our original image A, and gi is key point descriptor in our second image. Okay, so if the distance if we are getting a smaller distance between this fi and gi, the more likely they represent the same point in the scene. So by that we can actually match the descriptors. Okay, so by for that we have this distance formula already we have discussed, but as we are studying this matching key point, it is again important to discuss this distance function. So distance function also called as norm function. Okay, so we have this norms, okay, L1 norm, L2 norm, or a generalized form LP norm. So what is this LP norm? LP norm is LPFG. Okay, FG is nothing but F vector G vector. F vector is this vector of Fi's, okay, and G vector is vector of this GI's. So it is what, it is sigma I equals to 0 to n, that means summation of all the differences fi minus gi to the power p. Okay, and hold 1 by p. Okay, so that is LP norm. In this LP norm is a generalized form. If p equals to 1, we have this L1 norm, and if p equals to 2, we have this L2 norm. So these are the distance functions. Okay, so by this we can get the similarity. How we can get the similarity? If this distances or this norms coming very small, so we can say that they are more likely to represent the same point in the scene. If the distances are large, there is less chance of similarity. So this is how distance function works. Okay, now we have this another distance function called weighted distance function. This is very much similar to L2 distance function, but in L2 distance function, what you are seeing whenever we are comparing the FIs and GI corresponding GIs. Okay, so here we are not giving weight. Here we are not giving weights or giving one weight, means equal weight to all the FIs and GIs. But here what we do is we give different weights. Okay, we give different weights for corresponding FI and GI. So that is the only difference. This is very much similar. Only one thing is added here. Only we are multiplying the weights over here. So that is weighted distance function. And same logic, if smaller distance, then more likely they represent the same point in the scene, otherwise different points. So this is the weighted distance function. We have other two similarity measures. One is called normalized cross relation. So this is the normalized cross relation. Covariance of FG, and then the formula, it is given by rho of F vector and G vector. How we find out? This is covariance of F and G, and divided by standard deviation of f into standard deviation of g. This is the formula of covariance of f and g, that is 1 by n sigma I equals to 1 sigma or summation I equals to 1 to n minus 1, and then I equals to 1 to n either you can write, or either you can write I equals to 0 to n minus 1, same thing, okay. Fi minus f gi minus g, and then we have this, okay. I equals to I by n, this is standard deviation of f. What is standard deviation of f? Standard deviation is nothing but root over variance, okay. So this whole thing is variance, 1 by n sigma I equals to 0 to n minus 1 fi minus f square, okay. And if we just put a square root of it, that is standard deviation. So standard deviation is nothing but root over variance, so that is standard deviation of f. Similarly, we have standard deviation of g over here. So by this we can measure the similarity, okay, normalized correlation. Similarly, we have this cosine similarity. Cosine similarity, again a measure of similarity, that is f dot g divided by norm of f, norm of g, that is nothing but root over or magnitude, or you can simply say this magnitude of f divided by magnitude of g. So these are some tricks how we can match the key point by distance formula or this similarity measures, okay. These are the two things. So is this slide clear to all of you? Is it clear? Okay, no problem. Let's discuss few questions, it will be more clear, okay. So this is the question number 1. So we have this f vector, that is this 3 2 4 5 1, and we have this g vector 7 2 5 3 2, okay. And we have been told to find this f minus g 2, that is nothing but L2 norm, okay. Don't get frightened by this sign, it is nothing but L2 norm, okay. That is why 2 is given. This sign, whenever this sign is there, that is 2 mod sign, okay. So that is nothing but norm, okay. And 2 written means that is denoting this is L2 norm, okay. So L2 norm we have to find. So L2 norm, it is very simple. What is the formula of L2 norm? This is the formula of L2 norm, okay. Sigma I equals to 0 to n fi minus gi square, that is for all the points. We have to do the summation and then root over the whole thing, okay. So that is L2 norm. So very easy. First what we will do fi minus gi, okay. So fi minus gi, let's start, okay, yeah, fi minus gi, we will 3 minus 7, then 2 minus 2, then 4 minus 5, then 5 minus 3, then 1 minus 2. By this we can get the f minus g, that is coming this. And once we got the f minus g, it is very easy. What we have to do, we have to sum over the squares, okay. So sum over the squares and then root over, that is our L2 norm, sum over the squares. So once we got f minus gi, fi minus gi, we have to do what we have to do, we have to square of all the fi minus gi's, and then we have to do the root over. So let's just square and add up. So square and add up, this step we have just square and add up, that is coming 22, and then we have to root over. So it is coming root 22. So this is the first question of L2 norm, okay. So is this clear to all of you? L2 norm, is it clear? Am I audible? Okay, nice. So simple question. So similarly you can find L1 norm also and LP norm also, okay. P value, if it is given anything, you can directly find the L1 norm or LP norm. Similarly we have the second question. So using the same f and g, that is this f and g, okay, and weights here is given. So we have to find this weighted this thing, okay, weighted distance function we have to measure, okay. So how we do the weighted distance function? So this is formula, so very easy. Again we already have calculated fi minus gi, okay, that this. But now what we have to do, we have to multiply it by the corresponding weights. So weights are given 2 1 3 1 2. So just we multiply by weights. For example, fi minus gi square, first it is coming 16, okay. Now with 16 we have to multiply 2, then with 0 we have to multiply 1, with 1 we have to multiply 3. Similarly with 4 we have to multiply 1, and with 1 we have to multiply 2, and then add up and then do the root over. So same thing. So just what I have told just multiply it and do the summation and then the root over. So our distance is coming root over 41. So this is the distance weighted function. Okay. Then we have this question number 3. Is for the same vector, compute the cosine similarity. Okay. So this is the formula of cosine similarity. So how to do it? We already have f vector, we have g vector. What we have to do? We have to dot product f dot g and divided by by magnitude of f and magnitude of g. Okay. So f dot g, just find out the f dot g. First step is find out the f dot g, and then you do the magnitude of f, that is this. Okay, and magnitude of g, that is this, and then do the cosine similarity, that this measure cos theta equals to the multiplication or f dot g divided by root over divided by this magnitude of f into magnitude of g. So magnitude of f dot g, this is the magnitude of f dot g, f into magnitude of g, and this is actually f dot g. So f dot g by magnitude of f, magnitude of g, and our answer is coming 0.876. Okay. So these are the 3 questions for similarity. We have another question. Now we have to find compute the normalized cross correlation. Okay. So this is the formula of normalized cross correlation, and covariance, this is the formula of covariance, and standard deviation, this is the formula of standard deviation. Standard deviation for x is given. If f we have to do, then we have to just replace the x by f. Okay. So fi minus f bar. So how we find out? So this is how we do. First we calculate the mean of f and mean of g, and then we do the deviations. Okay, that is fi minus f bar and gi minus g bar. Okay. Okay, fi minus f bar and gi minus g bar. Okay, and then we do the pairwise products. Okay, that is fi minus f bar and gi minus g bar, and then we add up. Why we do it? Because of this step. Okay, because of this step we have to but first do the fi minus f bar and gi minus g bar, and then we have to add up. Okay, and then we have to just add up. Okay, and once we add up, what we have to do for covariance? We have to do the we have to divide by the number of population. What are the number of population? As we have how many points? 5 points. So that is why divided by 5. Okay, and then do the root over. Okay, as here the answer is coming 1, so root over of that will be covariance we do not require root over, so that is why 5 by 5, whatever fi sigma f I minus f bar and gi minus g bar divided by number of points. The number of points here it is 5, and this product summation is also coming 5, so 5 by 5 equals to 1. So by this we got the covariance of fg. That means we are cleared with the numerator. Now we have to find the denominator. So denominator, how we have to find? We have to find the standard deviation of f and standard deviation of g. Okay, by this formula. So just find out the standard deviation of f and g. Okay, if we do not put the root over, that is variance. So that is why we first find out the variance, and that standard deviation is nothing but root over this thing. So just find this thing, 1 by n sigma xi minus x bar. Okay, that is standard deviation of x. But here we have two function f and g, so that is why 1 by n sigma fi minus f bar. We already have fi. Okay, fi, that is all the f's, and what is f bar? F bar also we have calculated here. So it is very easy to find the fi minus f bar and do the square it and do the summation. We have just squared it. We have find the fi minus f bar. Okay, so fi minus f bar we have find out. This is the fi minus f bar. And then what we have do? We have just squared it, not square root, squared it, and then sum it. Okay, add all the things, and then by this and divided by number of points, that is 5. By this we got the variance, and standard deviation is nothing but root over of that variance. Similarly, we can do for the g. So we are cleared with standard deviation of f, standard deviation of g, and now what we can do? It is very easy to get the standard deviation of f dot g, and then we can do the normalized cross coefficient value. We already have covariance, and we have this 2 standard deviation of f and standard deviation of g. So we will get the answer. Okay, so this is how you solve the normalized cross correlation. Okay, so any doubt in this? Any doubt in this, you can please ask. This question, it is very important, because whenever you are asked this similarity measure, this question is always asked. Okay. So any points, any doubt, you can please ask. No
Hello.
problem. Yeah, please.
Sir, here F bar and G bar is there, right?
Yeah,
Under
that is
step
mean of f
2,
and mean of g.
how to find F?
How to?
How to find F minus F bar?
F minus f bar.
Where is value?
F is, yeah, f is, we already know, right? F is, the previous question is only repeating. We have this f's. Okay. And once we got the
Okay,
f bar,
from number one only we have to continue. Okay,
no,
understood, sir.
yeah, f minus f bar. So f bar is nothing but mean of it. So 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 5 is 14, and 14 plus 1 is 15. 15 divided by 3, 5. So f bar is 5. Okay, so f minus f bar. So that is 3 minus 5, 2 minus 5, 4 minus 5, 5 minus 5, and 1 minus 5. Similarly, you can find the g minus g bar. Okay, clear, right? So this is f, and
Okay.
similarly this is g bar, and similarly this is f minus f bar and g minus g bar. Okay, and then these are the steps. Any other doubt in any other steps, you can please ask. No problem. Clear, right? So you can solve this type of question, right? Okay. So by this, let's move on to this matching criteria. Okay, so matching criteria, we have distance based matching. So in distance based matching, we have these three things. One is fixed threshold. What we do in fixed threshold, we fix a threshold. Okay, and then we say that if our distance of that point, okay, distance of that point is coming, distance of that point is actually coming lesser than the threshold, then we accept that point, or we say it is a valid matching. Otherwise, we say it is an invalid matching. So that is fixed threshold. Similarly, we have this nearest neighbor. Okay, report the nearest neighbor. That is the thing, and then nearest neighbor distance ratio. This is very important. So what is this nearest neighbor distance ratio? So we have a fixed point. Okay, from this fixed point we have this, like we have this two neighbor. One is this blue color neighbor, and one is this red color neighbor. Okay, and then what we do, we find the distance from that fixed point. Okay, this is the fixed point. Let's say this is the f. Okay, and we have this two neighbor. This is, let's say this is n1 neighbor, and this is n2 neighbor. Okay, then what you do, you find the distance of distance of n1 neighbor, that is d1, and distance of n2 neighbor, that is d2, and you just calculate this d1 by d2. Okay, this thing, just calculate this d1 by d2. If the d1 by d2 is coming lesser than threshold, then you say it is a valid match, or you accept the point as a key point. Otherwise, you say it is not a valid match, and you reject the point as a key point. Okay, so that is matching criteria. Now we have this other matching criteria, that is known as matching histograms. What we do in histograms is, we construct histograms. Histogram is nothing but, you can say, a bin of similar points. Okay, that is a histogram. So you construct histogram. How you can construct? You can either use a LP norm. Okay, so you can just calculate a LP norm, and you can form a bin of different sizes. Okay, different, same size, but different bins. Okay, and you just say the threshold of each bin. If the point is coming, if the distance or LP norm is coming less than this threshold, you put in that bin. Otherwise, you put in the next bin. Okay, so that is how you can do it. So LP norm, generally we use L1 norm over here. Then we have something called Kullback lever divergence, or PDF formula. So PDF, you find the distance by this. Okay, and then again you do the same bin thing. Okay, if it is lesser than threshold, you put it in one bin. Otherwise, you put it in next bin. Okay, so this is formula is very important. So just remember the formula, and you can solve the question. And third, we have this again, another distance measure called earth mover distance. Okay, so here we have this two normalized histogram, p and q. Okay, Yeah, so we can discuss in a question, will be better clear. Okay, so let's move on to the question directly, it will be clear better. So suppose we have this two descriptor, one is f12 and g13, okay, and we have to find the L2, yeah, the L2 distance is given by this. If fixed threshold 1.5, is this a valid match? Okay, so that is the question. If the fixed threshold is 1.5, it is a valid match or not. So how we will proceed? We will first find the distance. Okay, so if the distance is not given, you are first to find the distance. Okay, once you find the distance, if the distance is less than a threshold, okay, threshold is 1.5 but the distance is lesser than threshold, then the key point match, or it is a valid match, otherwise it is an invalid match. So that is nothing but this is what I have told it in fixed threshold. Okay, if the distance is coming lesser than threshold, then it is a valid match, otherwise it is not a valid match or an invalid match. Okay, so this is the first question regarding the threshold value or the nearest neighbors. Okay, and then exercise 6, this is the f, and we have this two candidate g1 and g2. Now which is the nearest? Okay, use Euclidean distance to get which is the nearest. So very easy. So what you can do, you can just calculate the Euclidean distance. Euclidean distance, it is very easy. What is Euclidean distance? That is x y2 minus y1 plus x2 minus x1 square. Okay, so that is, either you can write like this, x2 minus x1, okay, x2 minus x1 square plus root over root, same root, plus y2 minus y1 square. Okay, y2 minus y1 square, y2 minus y1 square, root over of all. Okay, so x2 minus x1 square plus y2 minus y1 square whole root. Okay, so that is Euclidean distance. So you can just find the Euclidean distance, like 3 minus 2 whole square plus 1 minus 1 whole square. Okay, so 3 minus, actually it will come 1. Okay, similarly g2, that is 2 minus 1 whole square plus 1 minus 0 whole square. So that is 2 minus 1 is 1 plus 1, that is coming root 2. Okay, so 1 is coming 1 and this is coming root 2. So actually g2 is farther away and g1 is nearer. Okay, so that is the thing, like distance of fg1, it is coming 1, and distance of fg2, it is coming root 2. Okay, so g1 is nearest to this f. Okay, so that is how you do the nearest neighbor sum. Similarly, we have this exercise 7 for f and g. We have this g1 and we have this g2. If the threshold 0.75, then it is a valid match or not. So for this we have to use nothing but our this nearest neighbor distance ratio, or NNDR. Okay, so NNDR, what I have told, if d1 by d2 is less than threshold, then we accept or say it is a valid match. If d1 by d2 greater than threshold, then we say it is not a valid match. Okay, so same thing, you just find the d1 from here and you find the d2 from here. Okay, so fg1, distance of fg1 is d1 and distance of fg2 is d2. Okay, and then you calculate d1 by d2. If d1 by d2 lesser than threshold, then it is a valid match, otherwise it is not a valid match. So let's calculate it. So d1 or df of g1 is coming 1. Similarly, df of g2 is coming 3. And d1 by d2, 1 by 3, that is 0.33. As 0.33 less than 0.75, so it is a valid match. Okay, so that is how you solve the nearest neighbor distance formula. Okay, and then we have this question, that is earth movers distance. That is very important. Okay, that many times concept of it is not clear. Kullback divergence distance is very easy. That is simple formula, but you always find out a problem in this formula. With Kullback KL divergence, we will solve a question in the numerical part, or whenever we will be discussing the assignment type question. There we can solve one question of KL divergence. But this earth mover distance is actually, that is a different type of concept, and it is always tricky. Okay, so what is this? Again, just let me recap. This is the EMD formula, or earth mover distance formula of P and Q. Okay, that is sigma I equals to 1 to m sigma j equals to 1 to n fij and dij, and similarly sigma I equals to 1 to m sigma j equals to 1 to n fij. Okay, so don't get confused of m and n etc. So basically f ij dij it is a matrix and fij is a matrix. So sigma 2 sigma means we are summing both the rows as well as column. So nothing, you have to 2 sigma are there, that means we have to sum up each element of that matrix. Similarly we have to sum up each element of this f matrix as well as f dot d matrix. That is the formula. Okay, now what is P? P is the source distribution or the supply. What is Q? Q is the target distribution or the demand. That is how we define this P and Q in the EMD or earth mover distance. What is this Fij? It is the flow or how much mass from bin I of P is moved to bin J of Q. So that is why it is known as EMD or earth mover distance. We are actually moving mass from one bin to another bin. Okay, so that is why this is known as earth mover distance. That means we are moving from one bin to another bin. We have this two bin. One is the source bin and Q is the target bin. So we have to like transfer from one bin P to another bin Q. So how much mass is transferred from bin I of P to bin J of Q, that is given by Fij, and Dij, that is the ground distance between bin I and bin J. Here in the question the ground distance is given by this, that is Dij is mod of I minus J. So what does that denote? It denotes the ground distance or absolute index reference. I is the row index and J is the column index. So that is how we write it. So Dij, how we can write the matrix? So first element is 1 1, right? So 1 minus 1 is 0, and mod of 1 minus 1 0 is 0. So that is why 0. Similarly second element here is 2 1. Okay, so 2 1, again 2 minus 1, that is 1, again mod is 1. Similarly this is 1 2, 1 minus 2 is minus 1. So minus 1, mod of minus 1 is 1. Okay, so that is why 1, and then 2 minus 2 is 0 and mod again 0. So that is how you get the D matrix. So already you got the D matrix. Now if we got the F matrix, then we can just do the F dot D and we can divide it by F. Okay, and we can get the earth mover distance. Now how to get the Fij matrix? So Fij matrix can be found that how much mass we can transfer from bin P to bin Q. Okay, so this is our bin P and this is our bin Q. Okay, so how we can transfer? Like 0.4. 0.4 is your source, but here the target is 0.5. So you can easily transfer 0.4 to 0.5. Because 0.5 is less, 0.5 is more. So you can move all the source to the target. Okay, so that is why F11 can be given by 0.4. Okay, now after you transfer 0.4 to 0.5, still you have this deficiency of 0.1, right? So to clear that deficiency, you can take help from 0.6. So 0.6 is 0.6, but your deficiency here is 0.1. So that is why you can just move 0.1 from here to here. Okay, so just move from 0.6, you just move 0.1. So that is why your F21 is 0.1. Okay, so deficiency or this target is over. 0.5 target is over. Okay, now from 0.6 you have 0.5. Okay, so 0.5 you can easily move 0.5 to this 0.5. Okay, so you can easily move 0.5 to 0.5. So that is why here this. Okay, but 0.5 here, as the bin is already over, so you need not to transfer anything from here to here. So that is why 0. Okay, so by that you can get the F matrix. Once you got the F matrix, you already have this D matrix. You can get the sigma Fi j Dij. Just multiply the elements. Okay, 0.4 into 0, 0 into 1, similarly 0.1 into 1 and 0 into 0.5. So just add up and you get the sigma Fi j Dij. Once you got the sigma Fi j Dij, and you can get the sigma Fij. That is very easy. You have this, just sum up all the elements, 0.5, 0.5, so 1. So sigma Fij is coming 1, and you have sigma Fij Dij, that is coming 0.1. So 0.1 by 1, that is 0.1 is your earth moving distance. Okay, so that is how you solve the earth mover distance problem. So is it clear how you form the Fij? Is it clear? Dij should already be given, but Dij can be given in a different type of form. But it is very important to calculate the Fij. So clear, right? How to calculate the Fij?
Sir, please explain one more time. Final
Fij.
flow metric, how it is calculated?
Yeah, Fij, right? Okay. Nice.
Yes.
Yeah, yeah. Okay, so we have this two bin. One is P and one is Q. Okay, P is known as source bin. Okay, Q is known as target bin. That means we have to transfer from this P bin to Q bin. Okay, that is our target. Okay, so that is our target, and that target we achieve by our F matrix or the transfer matrix or flow matrix, anything you can say, transfer matrix or flow matrix. So that is our F. Okay, so how we flow from supply source to target, that is our flow matrix or this transfer matrix. Okay, now F11, how F11 can be formed. So let's see from this target and see from this source. This point 4 can be transferred to point 5, right? Point 5 is our target, but we have this source point 4. So easily target, or you can say demand. So this is demand. Point 5 is our demand in Q, but we have this supply point 4. So point 4 whole can be transferred to point 5. Okay, so that is F11. So we are cleared with F11. Okay, one is from this index and one is from this index, that is why F11. So point 4 can be easily transferred from this index, this bin to this bin. Okay, because supply is 0.5 here and source is 0.4 here. Okay, or sorry, the demand is 0.5 here and supply is 0.4 here. So the whole supply can be transferred to cater the demand of Q. Okay, so that is why 0.4 we can easily write. Okay, so is the first element clear? F11. Point 4, our
Okay,
demand was
okay,
point
okay,
5.
sir.
Yeah, our
Let's see you
demand.
transfer from point 4
Yeah. So point 4.
P11 position to Q11 position,
Yeah,
right?
yeah, yeah, yeah. So F11 is clear. Now what about F12? Okay. So yeah, this F12 or F21. Let's take F21 first, because point 1 is still our deficiency. Okay, point 4 is already transferred. So to cater point 5, point 4 we already got, but point 1 we do not got. So that is why we take the point 1 from this bin. Okay, so that is why our F21 will be 0.1. Okay, 0.1 is the efficiency, so we can take 0.1 from 0.6. This already is over, but 0.6 is left, and here 0.1 is our demand, so we can easily take 0.1 from here. Once we take 0.1 from here, this demand gets fulfilled. So that is why F21 is 0.1. Okay, F21 is 0.1. F21 is 0.1. Is it clear what I told?
No, sir. Is it a point 0.6 minus point 0.5?
No, no, not zero point 0.6 minus zero point 0.5. Zero point 0.5 in zero point 0.5 comma 0.5, right? 0.5 from 0.4 we have the demand initially was 0.5, right? But 0.4 we have already transferred. So our demand 0.4 gets filled. Now 0.5 minus 0.4 is 0.1. So still we have demand of 0.1. Okay?
Okay, okay, okay,
Yeah,
sir.
now that point 1 can be taken from point 4 is already lost. Now point from that point 1 can be taken from point 6, right? So that is why F21 is point 1. Okay,
Okay, okay,
okay. Now
okay.
now about the next things. Okay, now about next thing. Now point yeah now we have left here point 0.5, right? Because point 1 already we have given here, so we are left from point 0.6, we are left with only point 0.5. Okay, this point 0.5, if we give this point 0.5 to here, we do not have anything, because here already the target is 0. Target is 0 because point 0.5 already got filled. Okay, so that is why f f1 comma 2 f1 comma 2 is actually 0 because target is already or demand is already filled. This point 0.5 demand is already filled, so that is why f12 is 0. Similarly, what about f22? We have this demand 0.5 and here we have this 0.5 left, so 0.5 we can easily give from here to here, so that is why f22 is f22 is 0.5. Okay, so by this we can form the matrix. We have f11, f21, f12 and f22, that is 0.5. So this is our matrix. Okay, so is the last step clear?
Okay, okay, sir.
Yeah, so this is the final flow matrix or transfer matrix. Okay, and once you got the transfer matrix, it is very easy. You do the f dot di and get the sigma of it in the numerator, and the denominator you just sum up all the elements of f matrix, and then this is the EMD is nothing but the ratio of sigma fi di by sigma fi, and by that you can get the answer. Okay, so is it clear? Earth mover distance, the concept is tricky, little bit tricky, but that is why I have solved the question to clear you out. Okay, Kullback divergence is very easy. That is a simple formula. We can solve one question in the assignment type of problem, and there it will be clear. Okay, so this is the thing. So I hope it is clear. Now let's move on to the next topics. Okay, so efficient computation of feature mapping. So whenever we are talking about feature mapping, there is a lot of computation. Okay, so whenever we are talking about this nearest neighbor, we are actually doing a ordinary linear time complexity or ON. So it is related to computer science. Every operation that we do, there is a type of complexity associated with it. So whenever we are talking all this distance, nearest distance, etc., etc., all that uses this linear time complexity or ON. So the problem is whenever we have this large number of data, whenever we have this thousands of descriptor, because we are comparing all the descriptor from image A to image B. Now we can have large number of descriptors. So if we have a large number of descriptor, so our computation will be very slow for the large number of descriptor as well as for large data set. That means too many images that if we compare, then also things will be slow, and also as we have so many descriptor in two images or corresponding two images, then also our operation can be slow. So to deal with it, we use the indexing or hashing. Okay, so indexing or hashing. So we have one type of indexing known as KD tree. KD tree is nothing but k dimensional tree. Okay, that is the full form, k dimensional tree. So how it works? It choose a dimension and split the data at medium or root node. So all the data points should be okay. Let me solve one question. The doubt will be more clear. So this is how it works. Let me just read it. Recursively partition into left-right child nodes. Each leaf contains a small set of descriptor. For a query, transverse the tree. Find the candidate descriptor quickly. So what it does it just form a dictionary. Okay, instead of the descriptor being so randomly arranged, it just form a dictionary. So now if the dictionary is formed, it is very easy to search the descriptors. Okay, so by that it actually increases the pace of your operation. Okay, so pros, it is actually efficient for small medium dimensional descriptor. Cons, it is actually degrade for high dimensional descriptor. So what it helps is, earlier our time complexity, that was the problem, is the linear time complexity, but now it decreases the time complexity to O to the power log n plus 2t. That means we are moving from linear time complexity to logarithmic time complexity, and logarithmic value is always lesser than linear value. So that is how we are decreasing the time complexity. Okay, so here we have two part. One is log n, it find the cell near the query point, and 2d is search around the cell in the neighborhood. Okay, so that is how KD tree works. So next we have a sensitivity measure called as LHS hashing. Okay, so two things, one is indexing, one is hashing. So indexing we already have See, now we will see the hashing thing. Okay, so idea, hash function map similar vectors into the same bucket with higher probability. Okay, so you can just imagine like if you are searching a type of genre song in YouTube. Okay, so if you got the similar genre song, then also your purpose can get solved. Okay, so local sensitivity hashing works on that same idea. So how it works? Choose a random projection vector hash function that is given by this formula. Each descriptor is hashed into buckets. A query descriptor is hashed only compare it descriptor in the same bucket. Okay, so it basically what it do, it categorizes this descriptors into buckets, and then whenever you do the query descriptor, whenever you just ask the query descriptor, the descriptor will only show the designated bucket, not all the buckets. So by that we will be saving our time or saving our computational complexity. Okay, so pros, it is very efficient for high dimensional data. It is used in large scale image retrieval. Cons, approximately it may miss some of the true neighbors, requires multiple hash tables for a good recall. Okay, so let's forget it. Analogy, okay, formula also let me discuss whenever we are solving the problem. And then analogy, if I do, KD tree partition the space hierarchically for fast lookup, good for moderate dimension, whereas LSH or the locality sensitive hashing, it hashes high dimensional descriptor into buckets, good for massive dataset and high dimension. Okay, so KD tree is actually used for good for moderate dimension, whereas this LHS, it can be used for massive dataset and high dimension also. Okay, so let's solve one question each, it will be more easy. What is the root node for the KD tree built from 0.23549647 using X split first? So it is very easy. Root node is nothing but the median node. Now how we can get the median node? Using X split first. Okay, so we will see only X. Okay, so just see the X, all the 4 data point we have, only see the X, because mentioned in the question we have to do X split first. So let's do the 2, 5, 9 and 6. So how we will arrange? We first arrange the 2, then we arrange this point, that is 4, then we arrange this point 5, and then we arrange 9, 6. Okay, so this is our first arrangement, this is our second arrangement, this is our third arrangement, third point arrangement, and this is our fourth point arrangement. Now what is median? Median is the middle data point, but whenever we are talking about median in this either it could be second or third, right? Second or third should be median, or second plus third by 2 in mathematics. But here we cannot do second plus third by 2 because we do not have this second plus third by 2 point. Okay, so that is why we have to choose either second or third. Basically in this type of problem we set the we choose the last data point. For example, if we are given 10 data point, we will if we are if we have this 10 data point, that is 5th or 6th. Okay, so always choose the 6th one. Okay, similarly here we have this 4 data points, so we have to choose the middle, that is 2 or 3. So you always choose the third as the third, or the n by 2 plus 1 as the median point. So our median point is 5, 4. So 5, 4 is the root node. So that is the answer. But it is always good if we just build the tree. Okay, so median is very easy, just do the median. So what I told you, sort by X. So that is how I have sorted. This is first, second, third and fourth. Now second or third can be the median, but here you always choose the third as your median. So 5, 4. So 5, 4 is your median, or 5, 4 is your root node. So 5, 4 is actually the answer. But let's also prepare the tree. So as this is the root node, you just put this as your B point. So let's say this is our A point, this is our B point, this is our C point, and this is our D point. Okay, now as this B point is our root node, or 5, 4 is our root node, so that is why we have done this 5, 4. Now we have to do the as the tree has got 2 branches, right? So that is why we will see what is the left branch and what is the right branch. The left branch will always be points that are lesser in magnitude to that point. The right branch will be point that are greater in magnitude to that point. So as we are doing the x splitting first, we will decide it by x. Okay, so 5 comma 4 is the root node. Now we are left with this point. So okay, one is 9 comma 6, one is 2 comma 3, and one is 4 comma 7. Okay, now how we will decide 2 comma 3 will come or 4 comma 7 will come? That how we will decide? Again we will do again we will arrange in there. But now what we will do is we will do the y split. Okay, so y split, y is 3 here and y is 7 here. So already y splitting has been done accordingly. So now again we will choose a median. So median, as we have two data points, so 1 and 2 both can be median, but here let's always focus second as our median. So here 4 comma 7 is our median. Now we are already left with one data point. Now we will do the x splitting. Again we will do the x splitting. So here we are doing the x split. In this position we are doing the y split. Okay, this position we are doing the y split, and again we will be doing the x split. So we do splitting alternatively. Okay, here also we will do the x split. So we are doing the alternative splitting. So again we are splitting it alternatively, and then yeah, so we have this only one point, and now even if we do not want to do the splitting, we can easily form the branch. Okay, and right splitting, it is very easy. As the point is greater than this, then right splitting is 9 comma 6. Okay, so that is how we form the KD tree. So is it clear how we form the KD tree? Is it clear? Okay, is it clear how we got the root node at least? Am I audible? Is it clear how we got the root node? Am I audible? Okay, no response. Okay, so let me repeat again. How we got the root node? We have this data point not in sequence. Okay, so first we have to make the data point in sequence. How we can get the data point in sequence? Either we have to choose x or y. Here in the question we already told we have been doing the x splitting first. So to do the x splitting first, just focus on the x coordinate of every point. Okay, and then choose then arrange the point according to ascending order, and then choose the median of that point. The median of the point is nothing but the mid value. Okay, and the mid value will be your median or the root node. Okay, so that is how we got the root node. So here it is very easy: 2 comma 3, 5 comma 4, 9 comma 6, and 4 comma 7. Okay, so these are the point. So how we get the root node? So we have to do x splitting first. Okay, so for the point A, x equals to 2. For point B, x equals to 5. For point C, x equals to 9. For point D, x equals to 4. So how we can arrange this in ascending order? That is 2, 4, 5 and 9. So that means A, D, B and C. Okay, A, D, B and C is our arrangement. Now what will be the median? Either D or B, right? So how we can choose if it is D and B? So D is at second position, B is at third position. So always we choose the next one, that is the third position, and by 1 plus 2. If it is mathematically, what you have to do, you have to take the 2 and divide it by sum up and divide it by 2. That is how in mathematics we do. But here we cannot do that median, because if we do that median, we will not get the same point. Okay, for example, if our point is our point is actually what our point is, we have this conflict between D and B, right? Yeah, we have this conflict between D and B. Now if we do D plus B by 2, that is 4 plus 5 by 2, that is 4.5, or 4 plus 7 by 2, that is 11 by 2, that is 5.5. So 4.5, 5.5 is nowhere in our list. So that is why we cannot do that type of median here. So we just choose the next value. If we have 10 values, so our median will be either 5th point or 6th point. So we will choose the 6th point. If we have 100, our median will be either 50 or 51, so we will choose the 51th value. So like that, okay. So we are choosing simply the next value. So here the next value is D and B, right? So next value is B, so we will choose B as our median. So B is actually the root node here. So up to this, is it clear to everyone? Is it clear? Yeah. Up to this, it is clear. Then you first do the X splitting. Okay. X splitting, how you do? The left node and right node. If we have a single root, okay, so there will be a left branch and there will be a right branch, right? So left branch will always take value lesser than that. Right branch will take value greater than that. So lesser than, what are the values we have lesser? We have either 4,7 or 2,3. But together they cannot occur. Okay, so for that we use the Y splitting. And right value, it is very clear, it is the greater value. We have one value, so right branch is very clear, that is 9,6. But left we have conflict, either it is 4,7 or 2,3. So for that, what we do the Y splitting here. So Y splitting, we will see 7 and 3. Okay, 7 will be the greater one will be become the root node and lesser one will become the left branch. Okay, so by that we are forming the tree B, D, C and A. Okay, so now is it clear? Okay, I think it is clear. At least the root node concept is clear. The root node concept is clear, you can form the tree. Okay, okay. So let's take one question from this LSH. Okay, so we have this given v1 0.2 comma 1 and v2 3 comma 2. v3 also we have given -1 comma -2, and hash function hv given by this. Okay, this one word is nothing but the weight w dot v, right? Sign of w dot v, that will give the hash value. Okay, hv is nothing but the hash value, and that is sign of w dot v. Okay, now if the sign is coming same, then we will put it in one bucket. If the sign is coming different, we will put it in another bucket. Okay, so very easy, we have to just multiply this weight by the points. Okay, so first we have to multiply this w into v1. Okay, so 1 into 2, 1 into 2, that means 1 into 2, 1 into 1, that means this thing 1 into 2 and 1 into 1, that means 3. Okay, so hv1 is coming 3 and sign of 3 is positive, so we are just taking plus 1. Similarly, we will do w dot v2, it is coming 5, again positive, so that is coming plus 1. But when you will do w into v3, you can check 1 into -1 and 1 into -2, that is -3, and that is sign is negative, so we will put it in another bucket. So that is why v1 v2 are similar points, as the hash value is coming same, so we are putting in v1 and v2 in bucket +1 and bucket -1 we are putting v3. So that is how we are doing this LSH. Okay, putting this vectors into putting the vectors or putting this point into different buckets or similar buckets, similar vectors into one bucket and different vectors into different bucket. Okay, so that is the concept of LSH. It is very easy. W into V you have to do, you have to check the sign. If the sign is coming same, the points will point will be belonging in the same bucket, otherwise point will be belonging in the different buckets. Okay, so that is how you have to do it. So is it clear to everyone? It is a very simple concept. I think it will be very much clear to everyone. Clear, right? Okay. Now we have this model fitting, so we are over with this feature matching. Now we will start the new concept known as model fitting. So what is this model fitting? So in computer vision, model fitting means finding the parameters of a geometric or statistical model that best explains a set of observed data points, that is key point, edge or 3D point. Okay, so that is model fitting. So how we write it? We write it as data, this is the D, that is a data, and then we have this model M, and we have to calculate the error. Okay, so we have to fit a model such that this error will be minimized. Okay, so that is the concept. So again I am repeating. So computer vision model fitting means finding parameters of a geometric or statistical model. Okay, so parameter, theta is nothing but parameter of model M. that best explain a set of observed data point. So how we can say that this model will be best explaining this data point? It is very easy. How we can say this model is best explaining this data point? It is very easy, by minimizing the error. If our error is coming less, then we can say our model is fitting the data points well, otherwise our model is not fitting the data point well. Okay. So let me not read this. This you can find in your lecture notes only. But let's see this. This is important. That is choice of model. How we make the choice of model. So first thing is error of fitting. That I have told you. But error, how you can find? There are different type of error. But we do the mean squared error. Okay. What is this mean squared error? Once you fit the model, your model will give something y hat. Okay. Y hat is nothing but the predicted value of x. Okay, you have this x, okay, x data point, x1, x2, x3, x4, etc. Okay, now you you fit a model on it. Okay, so that model will get predicted value. Okay, so y is nothing but f of xi. Okay, y hat, that is the predicted value, is nothing but f of xi. Okay, so that is the predicted value, y equals to f of xi. Okay, then you have actual value y, and that is nothing but the value associated with xi in real space. So you now mean squared error. Mean squared error is nothing but y hat I minus yi, mean squared error yi, okay, and divided by 1 by n. That is mean. Okay, squared means this square. So okay, so this is the predicted, this is actually the actual, this is yi. Okay, predicted, this is predicted, this is actual. The square of this divided by number of points, 1 by n. So that is how you calculate the mean squared error. So this should be less. Okay, if this is less, then our model fits well. Otherwise, we can say our model does not fit well. Second thing, we have this likelihood. Likelihood is nothing but probability of data given model. Okay, that we have to calculate. So probability of data given model, so we have something probability of model and probability of data. From that we have to calculate this probability of data given model. Okay, if the probability is high, we can say this model is fitting the data well, otherwise the model is not fitting the data well. Third, we have size of model, that is the number of independent parameter needed for the model to fit the data. Okay, so that is the size of the model. At fourth, we have training and test error. This is a concept that is taken from machine learning. Okay, so we have this two type of thing. One is training and second is testing. Okay, what is training and testing? Training means we have given the data points. We have given the data points xi and yi. Okay, xi actual, xi is always actual, and yi actual. Okay, so we are given the data points. Okay, we split the data into different set. One is the training set, one is the testing set. In training set, we try to fit the data and make a model. Okay, so if we compare that model with the training data, so that is known as training error. Okay, and second, we have test error, the data left. Okay, that we already reserve it for testing. Okay, so that data, if we do the if we do the error between this test data and our model, this is known as test error. Okay, so we have this two error. One is training error. We have this test error, training error from the training data set, test error from the testing data set. Okay, now how we can what we can tell about the training error and test error? If we have got a large training error, then the model is underfitting. That means the model will always underfit if we have large training data error. Now if we have low training error but large test error, then we can say our model overfit. That means it is generalizing well the training data, but it is not performing well with our test data. So that is why we can say our model is overfitting. So underfitting if we have large training error. If we have low training error but large test error, then overfitting. Okay, and low training and low test error is actually our ideal case. So from that we can get a very good fit. Okay, the model is a very good fit. Okay, so this is how we say about training and the test error. Okay, so is this clear about training error, test error? Is it clear? It is very important concept. error and training error, test error. Size of the model is okay, that is number of independent parameter. Likelihood is probability of data given the model. So these are the parameters from which you can make the choice of the model, whether your model is fitting your data well or not. Okay. So most most general thing that we use is error of fitting, that is mean squared error we calculate, and if mean square error is less, we say our model is fitting well, otherwise we say our model is not fitting well. Okay, so this is the you can say this is the most commonly practiced whenever we are choosing the model. Okay, so this is the thing. Okay, so let's move to the next things. Fitting a straight line over the 2D points. Okay, so we have this techniques. One is least square, total least total least squares, random sample consensus, and the Hough voting. So line fitting in varying context. So given point belonging to a line, to find the optimal line parameter, we just do the least squares. To handle outliers, we go for this RANSAC or the random sample consensus. And if there are many lines, then we do the Hough transform. Okay, so these are the things. So these are the techniques from by which we fit the line. Generally, we take the help of this least square or total least square. If we have more noisy data, then noisy data or more outliers, then we take the help of this random sample consensus. If there are many lines, then we choose this voting, Hough voting. Okay, so these are the 4 techniques. So let's start one by one. So we have this least square line fitting, that is the most generalized, or to find the optimal line fitting. So how we do it? So how our line will be, we are fitting a line, so our line equation will be y equals to mx plus c. Now we have to find what is m and what is c. So in Hough transform, in this least square line fitting, our m is given by this formula, that is covariance xy divided by variance x, and our c value is given by this formula, y bar minus mx bar. Okay, and then we have a measure of called goodness of fit, or r square, that is very popular. So what is this r square? Compares the variability in measurement not explained by the model to the variability in measurement. Okay, so generally it gives us the variability of y. Okay, r square gives the variability of y. Okay, so that is why, what is the you can say, what is the con of this least square line fitting? Con is regarding this r square. Whenever we are doing the least square fitting, so if we have a vertical line, then variance of y will be very less. If variance of y will be very less or close to 0, this goodness of fit will be infinite, which is not possible. So that is why this is one of the cons, or it fails completely for vertical line. So again I am repeating, very easy. We have to fit a straight line to the number of points. So straight line equation is y equals to mx plus c. So how we find m? M we find by this equation. C how we find by this equation. So if we have m, we have c, we can easily fit by the line. Okay, so let's let's solve this question. It is let's solve the question. Then we have this total least square. Again we have this matrix. This matrix we have to find a ut u, and then what you have to do, you have to find the eigen value of this. Once we got the from the smallest eigenvalue, we have to get the eigenvector. Once we get the eigenvector, we can easily form the line in total least squares. Okay, so that is the method of total least square. Let's solve one numerical each. That will be very easier to understand. So fit a line y equals to ax plus b. These are the points 1, 2, 2, 3, 3, 5. Using least square line fitting, we want to fit a straight line y equals to ax plus b to the point this 1, 2, 2, 3 and 3, 5. So very easy. We have to find y equals to mx plus c or ax plus b here. So m is nothing but a here, and c is nothing but b here. So very easy. We can find m by this formula, or we can find m by this formula, covariance of x comma y divided by variance x, and c we can find by this y bar minus mx bar. So very easy. So let's proceed. X bar, we will find x bar first, we will find y bar first, and then to find the a or m, as in our question ax plus b is written, so a or m can be found by this formula. Okay, that is covariance of xy, that is 1 by n, and variance of x. Okay, so 1 by n, here also 1 by n would be there, and here also 1 by n would be there, as 1 by n is both in numerator as well as denominator. That's why 1 by n is cancelled, and we do not need to care about 1 by n. Okay, so that is the thing. And then you just compute the slope, and your slope will be coming 1.5. Just put the formula and your slope will be coming, that is m or a you are finding. And once you got the m or a, it is very easy to find the c, that is y bar minus mx bar or ax bar. Okay, so c or b can be found by this, so very easy. Y bar, we have y bar, okay, and we have x bar, and we all have also find the m or a. So we got the intercept b, and once we got the slope, once we got the intercept, so y will be nothing but slope into x plus intercept. Okay, so that is y line equation. So our slope is 1.5 and intercept is 0.33. So that is how we are fitting the line by from this 3 points. Okay, so that is the thing. So is it clear to all of you? Least square method, it is clear. Is it clear to all of you? Clear, right? We have one simple formula that you can apply. There I think calculation will be less, so I can give whenever when we are solving the assignment type question. There I can show. That is the second solution to it, but this is the primary solution. Okay, you need to keep in mind. Second solution is there. There I think you are getting a little less calculation, so that also I will show you. But this is the general technique to solve this least square line fitting. Okay, now let's see one question regarding this total least square method. Okay, so we are given this 3 point and we have to fit our lines. Okay, so how we will do it? First we need to center the data. Okay, so center the data is nothing but just find the mean. So mean of x is 2 and mean of y is coming 3.3, and then you have to center the data. Center of the data is nothing but x minus x bar, y minus y bar. So just do the x minus x bar and y minus y bar from all the points. So once you center the data, you can form this covariance matrix. Okay, so this is the covariance matrix after data centering. Okay, if you are not centered the data, then you have to write x minus xi, x minus x bar square, x minus x bar, y minus y bar, and x similarly. Okay, y minus y bar square. Okay, if you are not centering. If you are centering the data, you can easily write like this. As I have already centered, so I have directly written like this. Okay, if you are not having this step, then you have to write x minus x bar square, x minus x bar, y minus y bar, like that. Okay, as I have already centered, then easy. Okay, so sigma x square at this corner or 1 1 at 1 2 we have this sigma xy, 2 1 we have this sigma xy, and last 2 2 we have this. Okay, sigma y square. So once we can get the covariance matrix. Once we got the covariance matrix, we have to find the eigenvalue. Okay, how we can find the eigenvalue? Very easy. C minus lambda I mod of it will be equal to 0. Okay, so that is how we find the eigenvalue. So from this, as it is a 2 cross 2 matrix, we will be getting 2 eigenvalues. So we are getting 2 eigenvalues. One is lambda 1 equals to 6.62, and the one is lambda 2 equals to 0.05. Then our slope and intercept will come from actually the eigenvector of smallest eigenvalue. So what is the smallest eigenvalue? This is the smallest eigenvalue. So our eigenvector will come from this smallest eigenvalue. So you can just calculate the eigenvector from this eigenvalue 0.05. It is very easy. You do the c minus lambda already you have, and you do the v into it. Okay, so someone is joining. Yeah, you multiply the vector to it, and by this v is nothing but the eigenvector for this eigenvalue lambda. Okay, and you are getting the eigenvector minus 1.538 and 1. And best is to normalize it. So just do the normalization. What is normalization? You just divide it by the magnitude of it, okay? That is root over minus 1.5 square plus 1 square, okay? That you do for both x and y. So by that you can get the normalized eigenvector. Once you got the normalized eigenvector, this is the equation of line. Nx is the normalized x eigenvector, and y is the normalized y eigenvector, okay? And if we have this nx, this is nx, we have this ny, we have this x bar, we have this y bar, so we can easily get the equation of the line, that is coming 1.54 plus 0.26, okay? So that is how you solve the problem by total least squares, okay? So is it clear to all of you? Any doubt?
Sir, why you choose lambda 2?
Lambda 2, we have to get the eigenvector for the smallest eigenvalue for that equation, okay? Nx x minus x bar plus ny y minus y bar. For that we have to choose vector for the smallest eigenvalue, okay?
Okay, okay.
Okay. Yes, any other doubt regarding this question? So now you can solve, right? The least square or the total least square, you can solve it, right? Both the question. Let me again show you. Yeah, this is the question of total least square, and this is the question of least square line fitting, okay? So both I think you can solve. This is the equation, m equals to, this is the equation. So yeah, this is the equation, m and c for our least square, okay? And for our total least square, this is the equation, nx x minus x bar, ny y minus y bar. Nx and ny are nothing but your normalized eigenvector values for the smallest eigenvalue, okay? Once you got that, you can easily form that. And what is this eigenvalue coming from? That is coming from the covariance matrix, okay? So first you need to form a covariance matrix, and then you need to calculate the eigenvalues. Once you got the eigenvalues, you just choose the smallest eigenvalue. From that you get the eigenvector. Once you got the eigenvector, you just do the normalized, you just calculate the normalized eigenvector values. Once you got the normalized eigenvector value, it is very easy. You just have this equation, you put the values in the equation, and you get the equation of the line, okay? So I hope this two question you can solve by this methods, least square and total least square. Clear, right? It is very important actually in the context of line fitting. Clear, right? At least the steps clear, right? Okay.
Please, one more time you explain
Which one?
after that equation, sir. 1.95x plus 3y equal to 0. So from that you calculate x equal to above. Yes, sir.
Yeah, this one.
Yes, sir. Yes, sir.
Yeah, so see how you form the eigenvector. So yeah, what is eigenvector? Eigenvector is this equation, okay? C minus lambda into v. Lambda, you have this lambda value, right? Smallest eigenvalue you take 0.5, okay? This 0.05 and 6.62. So smallest eigenvalue is 0.05. So you take this, okay? And if you will take this c minus lambda, your c is this. So 2 minus 0.05, 3 minus 0.05, sorry, not 3 minus, c minus lambda I, right? So only in the diagonal, okay? So where is my cursor? Yeah, this. Yeah. So only take the only take the diagonal, okay? C minus lambda I is nothing but 1001, right? So your values are only in diagonal 1100, okay? Apart from the diagonal you don't have value, so c minus lambda is, so c minus lambda into 1, okay, at the diagonal. So only focus on the diagonal. So our diagonal is 2 and 4.67, and this 3 will remain same. So 2 minus 0.05, similarly 4.67 minus 0.05 into v, that will be equal to 0. So v, you take x comma y, okay, x y. So this is our equation, and v, you just take x y, and you form equations, okay? So whenever you will form equation, so you can get two equation 1.95 x into 3y will be equal to 0. Similarly, you can get another equation 3x plus 4.62 will be equal to 0. Okay. Now you got this two equation. Either you can just solve x and y, or you can take one value and you can get the xy ratio. Okay, you got the xy ratio. X is this much y. Okay, so let's say y equals to 1. For y equals to 1, you will get x equals to minus 1.538. Okay, once you got minus 1.5381, you just do the normalization. Normalization is nothing but divided by a square plus b square, that is minus minus of 1.5 square plus 1 square. Okay, by that you will get the normalized values. Okay, so that is how you do it.
Sir, how 1 in y question minus 1.538 comma 1?
Yeah, yeah.
How 1, sir?
How 1? We just assume y equals to
Yes.
1. Okay, for making this
Okay, okay.
even vector calculation simple. Okay, we just do the
Okay.
ratio and then we assume y equals to 1 or x equals to 1, anything which is good. So generally we assume y equals to 1 and find x. Okay, and then we just normalize it. That is how we can simplify this even vector calculations. Okay, so this is
So
the thing.
normalization means modulus of that value divided by modulus of that value.
Can you please repeat?
Normalization.
Yeah, normalization is divided by magnitude. What is magnitude? Root over minus
Root over
1.538
1.538
square
whole square plus 1
plus,
square.
plus 1 square. Okay, so
Okay,
divide
okay.
both the values x and y by this value, and then you can get nx and ny. Nx is minus 0.838, ny is plus 0.545. Okay, so that is how you can solve the total least square. If it has not been asked in the question, you just have been given values, always go with that previous one. Okay, that is least square. Okay, no need to go for total least square, go for least square. Okay, that will be easier for calculation. Okay, so that is the thing. Here you have to form covariance matrix and then you have to do a much more calculation. That is why I always go for this, that least square calculation. Okay, that is more easier. Just you have the formula for m, that is covariance xy divided by variance x, and then you have this formula for c, that is y bar minus mx bar. Okay, so there you can easily calculate the m and c, and just y equals to mx plus c will be your equation. So that will be more easier than this. Okay, but you also should know how to calculate this least square, total least square. So that is why I have given a question here. Okay, clear, right? Okay. Now we are left with the other two things. One is RANSAC, that is random sample consensus. Why we use this? If we have so many outliers. Okay, so to handle outliers, outlier is actually one of the biggest problem when we are fitting the line. Okay, because if we consider the outliers with our data, okay, outliers are like points which actually does not form the pattern, but these are actually the points which are far away, but actually it does not contribute to the pattern. But sometimes we consider it. If we just go with this least square or this total least square, we also consider the outlier. If we consider the outlier, our fitting will be bad. Okay, so to deal with that outlier, we came with this random sample consensus. Okay, so idea, many points may be outlier, don't belong to any line. Instead of fitting all data, RANSAC repeatedly select random subset, fits a line and check how many points agree with it in layers. So we in this RANSAC we are only fitting lines with the inliers, not with the outliers. So here what we do, we just first find out what are the inliers point are. Okay, and we just expel, or we just don't care about the outlier. We only fit the line with only the inliers. Okay, so how we choose the inliers? First, we from 2 points, random 2 points, just pick random 2 points, we form a line equation. from that line equation what we do, we calculate the perpendicular distance to it, okay, and then we compare it by the threshold, okay. If the perpendicular distance is lesser than threshold, then those points are inlier. If it is greater than threshold, then those points are outlier. So that is the RANSAC, okay. Advantage works well even with greater than 50% outliers. Adaptive to noisy real world data, okay. These are the advantage, okay. So that is regarding RANSAC. So again I am repeating, whenever you have outliers, okay, if you are just fitting all the data points with the least square or the total least square, what will happen is the fitting will not be good, okay. Fitting will be very bad because you have also considered the outlier which does not have any say in the pattern that you are making, okay. So for that, what is best is we just expel the outliers. So how we can do it? We can do it by the random sample consensus method. How this random sample consensus method works is that randomly what we do, we pick 2 points, okay, and then what we do is uh, we form the equation of the line by these points, and then we calculate the perpendicular distance of all other points with that line, okay. If the perpendicular distance is coming lesser than threshold, then we say this is actually inlier points. Otherwise we say we say those other points we say as outlier. If distance is greater than threshold, we call it outlier. If distance is lesser than threshold, we call it inliers. And we only select the inlier point to now fit with the least square or total least square, okay. So by that we are explaining out the outline. So that is random sampling consensus, or popularly known as RANSAC, okay. So let's solve the question by this. We have been given 6 points, so these are the 6 points. Suppose RANSAC select 1 1 and 4 4 to form a candidate line, okay. So equation of line is y equals to x. Using inlier threshold sigma equals to 1, how many inlier does this line have, okay. So how we will solve? So already the points are being picked 1 1 and 4 4, and equation of the line can be found by this, okay. Equation of the line can also be formed by this y minus y1 equals to m x minus x1, okay. That is equation of the line, x minus x1, okay. So let's say we have this 2 point, right. We have this 2 point 1 comma 1 and 4 comma 4. By this we can form the equation of the line by this equation. If our equation of the line is not given here, it has already been given, so let's ignore it. If we have not been given and we have just given 2 points, so we can easily form the equation of the line by this. What is m? Yeah, important. What is m? M is the slope, that is minus of y2 minus y1, y2 minus y1 minus of y2 minus y1 divided by x2 minus x1, x2 minus x1. So that is that is the sorry, plus, okay. M is this y2 minus y1 by x2 minus x1. So for example, our y1 is 1 and y2 is 4, okay, and x2 is 1 and x2 is 4. So y minus 1 equals to m of x minus 1, okay. And m, how we can calculate m? M is y2 minus y1 by x2 minus x1. So 4 minus 1 by 4 minus 1, 3 by 3. So 3 by 3 is nothing but 1. So our equation will be y minus 1 equals to x minus 1. Minus 1 will get cancelled. Y equals to x will be our equation, okay. So that is how you can get the equation if you have 2 points, okay. Once we got equation from our 2 points, then next is to calculate perpendicular distance of all the 2 points. These are the 2 points, just to be ignore 1 1 and 4 4, okay. And we have to calculate the perpendicular distance of all other points, 2 2 3 3 5 8 and 6 minus 2, okay. So just calculate of 2 2 by this formula, that is axi plus byi plus c divided by root over a square plus b square. A and b is nothing but this, okay. So a is 1, b is minus 1. Actually this will be x minus y will be equal to 0, okay. X minus y will be equal to 0, that is x equals to y, right. So a is nothing but a is this, a is 1, b is minus 1 and c is 0, okay. So just do the AXI, BYI, AXI plus BYI plus C by root over A square plus B square. So root over A square plus B square will be root 2, and AXY minus AXY plus AXI plus BYI plus C you have to calculate here, and denominator is coming root over A square plus B square, that is coming root 2. Okay, by that you can get the di, or the perpendicular distance of all the point. If I choose this point, so our perpendicular distance will be A is 1, so 1 dot 2 plus 1 dot 2 plus minus of, because B is minus 1, right, minus of 1 dot 2 and C is 0. Okay, so 2 minus 2, that is 0. Okay, so the distance of point 22 with this line is coming 0. Similarly, you can get the distance of 3 comma 3, 1 comma 1 and 4 comma 4, no need to calculate here, it has been calculated to just show you, but no need to calculate. You just calculate 2 2 3 3, 5 comma 8 and 6 comma minus 2. 5 comma 8, your distance is coming 2.212, but this distance, your inlier threshold is 1, so this distance is greater than 1, so actually this is outlier. Okay, again 6 comma minus 2, 6 comma minus 2, it is coming, distance is coming 5.66, so again it is greater than our threshold, so that is why again it is a outlier. Okay, so we have 4 inlier point and we have 2 outlier. Okay, similarly you can repeat with other random choices. Yes, and then you can get the equation of the line that best fits. Okay, so that is RANSAC. So important is how many inlier and how many outlier points. So what you have to do, you have to form the equation of the line, you have to calculate perpendicular distance of that line from all the other points. Okay, and then you have to choose whether the points are inlier and outlier. If your distance is coming lesser than threshold, then it is inlier. If it is greater than threshold, then it is outlier. Okay, so this is the concept. Is it clear? Yeah, clear, right? Okay, nice. So let us move into the next thing, that is Hough transform. This is the last thing. So idea of Hough transform: instead of randomly sampling every point, vote for all possible lines that pass through it in a parameter space. Peak in this voting space corresponding to likely lines. Okay, so this is the actually line parameterization equation of our Hough transform: x cos theta y sin theta equals to rho. So we have this 2 parameter here. One is theta, that is the angle normal to the vector to the line, and we have this rho, that is perpendicular distance of origin to the line. So we have this rho and theta. With this rho and theta voting, we can say wherever this rho theta or the parameter peaks, we can say we can choose this line. Okay, so I am not discussing the theory, we will see with the question. Okay, so given 3 h point, 2 comma 2, 3 comma 3, 4 comma 4, we apply Hough transform with the line equation rho equals to x cos theta plus y sin theta. For theta equals to 45 degree, correspond rho values are. So very easy, rho value we can calculate. So we have this theta value, that is 45 degree. We have this points also, x and y. So we can easily calculate the rho values. Okay, so very easily we can calculate the rho values. So rho values is coming for 2 comma 2, rho value coming 2.828. For 3 comma 3, it is coming 4.242. 4 comma 4, it is coming 5.625. So basically you have to memorize this equation. Okay, rho value is given by x cos theta plus y sin theta. Okay, and step 3, all this 3 point theta equals to 45 degree, different rho values, as we are for a same line we have this theta or the perpendicular distance of different perpendicular distances. So we can easily say these 3 points are actually collinear. Okay, and more the points that for a particular theta, the more the points are collinear, we can say we will choose that point or that theta value. This theta is the thing, but the slope of a line, right? So more for a given theta value, more we are getting the more points in the same line, we can say this theta value actually holds. Okay, so as we are getting more number of points, so we are just assuming this theta value holds. So as simply we can say the equation of the line is theta equals to 45 or y equals to x. Okay, so that is the concept of Hough transform. So in terms of quotient, your quotient will come to find the row value. So you would be given points like this. You would be given the theta value. Your quotient will come to find the row value. Okay. So corresponding row value you can calculate by this equation. Okay. So that is regarding Hough transform. Okay. So this is the thing, and then we have this dealing with noise and etc. You can read it in the text. I am not explaining it. And then we have this comparison of line fitting model. This I have given for you. So again you can read. Okay. So let's move on to the assignment question. Okay, so topic from which week 7 assignment question are based. These are the topics: key point matching, matching criteria, efficient computation of matching, this KD and index, KD tree and LSH, and then we have this straight line model fitting. These 4 things. Okay, least square, total least square, RANSAC and Hough voting. Okay, from this your question will come. So let's focus on one question. Given two feature f and g, compute the normalized cross correlation and cosine similarity respectively. So can anyone tell what is the formula of cosine similarity or normalized cross correlation formula? First, normalized cross correlation formula. What is the formula? Can anyone tell? That is covariance fg divided by sd of f into sd of g. Okay, so that is the formula for computing normalized cross relation. And second, cosine similarity, that is f dot g, or the dot product of f dot g divided by mod of f mod of g. Okay, so that is the cosine similarity. Okay, so let's see. We have this f vector of f values are given and g vector or g values are given. Now we can easily solve it. Okay, this is the formula of this normalized cross correlation, that is also known as Pearson R coefficient. Okay, sometimes this might also have been asked, so it is always better to know the names of different names of the same concept. Okay, so this is another name for this concept, normalized cross correlation. Okay, so this is the formula, covariance fg divided by sigma f, or the standard deviation of f and standard deviation g. This is the formula of the covariance covariance of fg, that is sigma fi minus f gi minus g 1 by n. Okay, 1 by n would be there, but as we have root over 1 by n from here, root over 1 by n from here, so that is why root over 1 by n into root over 1 by n, it is 1 by n. Okay, and at the top also 1 by n, so we can ignore the 1 by n. Okay, so that is why 1 by n has not been shown here, but covariance n is nothing but this 1 by n into whatever has been written. Okay, similarly sd is 1 root over 1 by n of this, and sd or standard deviation of f, and similarly standard deviation of g is root over 1 by n of this. Okay, so 1 by n will be coming here, 1 by n will be coming here, and 1 by n will be coming here. This is the whole formula, but as 1 by n will get cancelled out, 1 by n into divided by root over 1 by n into root over 1 by n, so 1 by n gets cancelled out, that is why it has not been shown, and rest the formulas are there, so you can easily solve the equation to get the normalized cross correlation value. And similarly you can get the cosine similarity. It is very easy, f dot g divided by divided by mod of f mod of g. So f dot g you can calculate, and mod of f mod of g you can calculate, and you can get the cosine similarity. So answer is coming 0.632 and then 0.849. Option B is your correct answer. Okay, option B is your correct answer. So is it clear to all of you? So let's move on to the next question. We have this two distances, the d1 and d2, be the distances of the nearest and the next nearest neighbor from a query feature respectively for a threshold limit 0.6. Choose the correct option. Nearest distance ratio d1 by d2 accept nearest neighbor as a match. Nearest distance ratio d1 by d2 rejects nearest neighbor as a match, both a and b or none of the above. Okay. So how you can do it? Can anyone tell what will be the step? Very easy. We have to first calculate d1 by d2 and then we have to compare it by the threshold limit. Okay. If d1 by d2 lesser than threshold, then we accept it as a match, otherwise we reject it as a match. So d1 by d2 is 10 by 8. Okay, 10 by 8. So 10 by 8 is actually greater than 0.6, right? It is 1 point something, so it will be greater than 0.6. As it is greater than 0.6, so we reject the match. Okay, so option B is a correct answer. Okay, so let me show you. So very easy, d1 by d2, you just do the d1 by d2. If it is lesser than threshold, then it is a match, otherwise it is not a match. Okay, so as d1 by d2 coming 1.25, it is greater than 0.6, so it is not a match, so our match is rejected. So option B is the correct answer. Okay, so this is the thing. Is it clear to all of you? Clear, right? Now find the KL distance between A and B with the probability distribution it has been given, this and this respectively. So you have to find the KL distance between A and B. Okay, so very easy. Just apply the formula. This is the formula of the KL divergence formula, dKL, that is given by sigma I pi ln pi by qi. Okay, so very easy. Just we have this pi values p1, p2, p3, p4, p5. You have this qi values q1, q2, q2, q3, q4 and q5. You can just find out this sigma pi ln pi by qi. So one point you can choose. You can calculate this and then at last you can sum up all this. Okay, so that is what I have done. One point I have choose, point 2 and point 3 I have choose. I have find this, and then point 4 and point 35 I have choose. I have found this thing, and then at last I have just sum all up, and that answer is coming 0.0129. So option A is your correct answer. Okay. It is very easy, but one thing you always should understand, that if probability distribution is given, all this A and B, that is nothing but PA and PB, actually these are probability distribution, then only we can apply this formula. If it is just values and not probability distribution, then we cannot apply this formula. So if only values are given, so what you have to do, you have to first find out the probability distribution. How you can do? You can just sum up all that, sigma p you can find, and then pi by sigma pi you can do that, and you can find the pi values for all A and B. Okay, so this is how you can do it. So is it clear what I have told?
Yes, sir, that's clear. But I just want to know if the logbook is provided during exam, because we have to calculate log values of this.
No, I think you will be provided calculator or not. Okay, I will ask. Actually, I also not know this. But even if, yeah, log values will be provided, otherwise you have been given a scientific calculator or that gate type calculator. Okay, so that you will be provided.
Okay.
So in that calculator, you will,
Calculator is allowed
no, not allowed. You will be provided on the screen. Okay, if it is a
on the
CBT,
screen.
yeah, on the
Okay.
screen it will be given, I think. Okay.
So that is computerized one, or
Yeah,
it's kind of a.
computerized one. Okay.
Okay.
So from that calculator you can easily calculate. If it will not be provided, then definitely you'll be provided with the logbook. Okay. Okay. So let me move on to the next question. So option A is correct. Now question number 4. RANSAC is best suited to find the optimal line parameter when point belonging to a line are given. Option A true, option B false. Can anyone tell? True or false? Okay, why RANSAC is used? Because of outlier. Okay, if we have to handle outlier or so many outliers are there, then we use the RANSAC. Okay, so actually it is false. Okay, RANSAC is designed to fit a model robustly in the presence of outlier. Okay, so presence of outlier, if it is there, if all the points perfectly lie on the on a line, if we do not have outlier, then we can easily use this least square or total least square. Okay, if we have so many outlier, then we go with this RANSAC, because computationally it is expensive, right? Because in RANSAC you have to first find out whether some points are outlier or not. After that you can do the least square or total least square. Okay, so that is why this is a false statement. So RANSAC is best suited to find the optimal line parameter when points belonging to a line are given is actually misleading. Okay, this statement is true for your least square. Okay, not for this RANSAC. Okay, so this statement that has been given, this is actually true for least squares, not the RANSAC. Okay, so that is why this is a false statement. So is it clear? Clear, right? Okay. Question number 5. Which of the following method is best suited for line fitting with outlier? Again the same question. Least square, RANSAC, Hough transform, and Kullback Leibler divergence, scale divergence. So I hope it is clear. Which option?
B is the answer.
Yeah, RANSAC is the answer. Same type of question. Again repeated. Yeah. So least square, it is sensitive to outlier, not suitable. RANSAC, robust to outlier and best suited. Hough transform, it can detect lines and images, but is computationally heavy, not usual for outlier handling. And KL divergence, it is actually a different thing, used for comparative probability distribution, not for line fitting. Okay, so it is used for this feature matching thing. Okay, not for this line fitting. So option B is the correct answer. RANSAC is the correct answer. RANSAC is best suited for line fitting with outliers. Okay, so this is regarding question number 5. Now question number 6. Low training error necessarily indicates overfitting. Is it true or false? We have two cases, right? One is underfitting, second is overfitting. If our training error is more, then we can easily say it is a underfitted model. But regarding overfitting, when we can say overfitting, if our overfitting, when we can say if our training error is less but our test error is more, then we can say our model is overfitted. Okay, so this is actually a partial statement or the incomplete statement, so that is why this is a false statement. So again I am repeating, we have two conditions. One is underfitting, second is overfitting. If we are getting a high training error or a large training error, then we can easily say the model underfits. Okay, if we are getting low training error but high testing error, so we can say our model is actually overfitting. Okay, so this is the concept. So this is actually a partial statement, so that is why we cannot say anything regarding this. So that is why this is actually a false statement. Okay, low training error means the model fits the training data well, but overfitting is indicated when training error low but validation or test error, or you can say validation error, is high. Okay, so low training error does not necessarily means the model overfits. Okay, so this is again a false statement. So is it clear? This is a very important concept. I hope this is clear. Clear, right? Is it clear? Okay, I hope it is clear to everyone. Yeah. So consider 2 points A and B in image space. Compute two lines corresponding to them in a parameter space. So how you can calculate? Very easy. Y equals to mx plus c, right? y equals to mx plus c. This is line equation in parametric form. Okay, it's just you can put the value of x and y and you can get the equation. Okay, y equals to mx plus c. Okay, so if you will put this point 1 comma 3, so your answer will be 3 equals to x plus c. 3 equals to x plus c. This is one equation, and another equation is b equals to 3 comma 5. So that is 5 equals to 5 sorry m. Okay, this is not x, this is m. 5 equals to x is what, 3, so 3m plus c. Okay, so these are the two equation. Okay, these are the two equation. So value is given, c equals to yeah, if we just write here, so c equals to 3 minus m. Okay, c equals to 3 minus m, so this will be right, and c equals to 5 minus 3m. Yeah, this. So option C is your correct answer. Okay, so very easy. Just you can just convert this c equals to y minus ms and just put the values. Okay, for first value this is your equation, parametric form of the line, and for the second point this is the parametric form of the line. So by that you can get the answer. So option C is your correct answer. Okay, so is it clear? Very simple question, but you should know what is a parametric form of a line, that is y equals to mx plus c. Okay, that you have to always keep in mind. So is it clear to everyone? Clear, right? Calculate the cosine similarity between these two. Again it is very easy, that is f dot g divided by mod of f mod of g. Okay, mod of f mod of g means magnitude of f magnitude of g. So you can easily calculate cos theta is this. Okay, f dot g, you can calculate f dot g, that is 3 into 4, 2 into 2, 8 into 8, 2 into 9, and 5 into 4. Okay, and it is coming 180. Mod f is coming root 106, mod g is coming, or magnitude of g is coming root 181, and you can get the cosine similarity. Okay, it is coming 0.851. So option B is your correct answer. Okay, so option B is your correct answer. Okay, so is it clear? Clear, right? This is another question. Choose the correct option. How transform requires appropriate resolution of these discretization of grid in parameter space. If grid are too coarse, too many different points in image space mapped to single bucket. If grids are too fine, some points may not be exactly collinear, voting different buckets. How transform does not require any discretization of the grid parameter space. So this is actually false. So actually it requires discretization. So yeah, this is false, very false. And let's analyze the options one by one. So the how transform works in parameter space rho and theta. Okay, similarly of m and c, but we in how transform we use this parameter rho and theta. Okay, so discretization or grid resolution is required to accumulate votes. Okay, second is if the grid is too coarse, many distant lines, okay, point in image space will map to the same accumulator bucket. Okay, if it is very coarse, okay, then what will happen in the same bucket, many lines will occur. Okay, so that will reduce the accuracy. If the grid is very fine, points from the same line may fall into the neighboring bucket. Okay, as the grid is very fine, so what will happen is point from the same line will form in two different buckets. Okay, so that is again that will again weaken the vote strength. And D is already false because discretization of parameter space is essential for Hough transform. Okay, and option is given does not require discretization. So option D is false, but option A is clearly right. Option B and C you can analyze from this. Okay, option D is false, and this is the correct answer. A, B as well as C is right. Okay, so this is the thing. These two things you have to just understand regarding how transform. That how transform always form a grid. Okay, Now if the grid is too close, that means the grid is very wide, okay, so that means what will happen is many lines will fall in the same grid. So what is the disadvantage of it? That will reduce the accuracy. Now if the grid is very fine, okay, what will happen is same line will fall in two different buckets, so that will weaken the vote strength. So that you have to understand. And then the first option is always right because we have this two parameter, okay, rho and theta. So correct answer is A, B as well as C. Okay. Now let's move on to the next question. Using the method of least square, find an equation y equals to ax plus b regarding this. Okay. So how we can do it? Either we can do it from this. Yeah, either we can do it from this. Yeah, either we can do it from this, okay, just calculate compute A by this formula, that is covariance of xy divided by variance of x, okay, that you can calculate a slope from, and intercept, how you can calculate? You can calculate intercept from this, okay, y bar minus slope into x bar, and y bar means the mean of y values and x bar is the mean of x values. Either you can calculate from this, okay, or you can calculate from the next method that has been shown in this problem, okay. Either you can simply calculate from that, okay, or you can calculate from this method. This method, what you have to do, you have to memorize this two equation, okay, you have to memorize this two equation, and once you memorize this two equation, you can just put the values in this two equation. From this you will get two equation of and two variables, and then you can solve to get the a and b, or the slope and slope and this intercept, okay. So either you can just follow from what I have told in the previous example question or example question, or you can follow this, but for this you have to memorize this two equation first. Once you memorize this two equation, it is very easy. You calculate sigma x square, you calculate sigma x, you calculate sigma xy, and you calculate sigma y. So sigma x, sigma y, sigma x square, sigma xy, if you calculate, then just put it, and you will get two equation, you have two variable, and you just solve it, and you will get the value of the slope and intercept, or a and b, okay. So this is another method to have to solve this least square, or you can easily solve from what I have told, that is m will be given by nothing but covariance xy divided by variance of x, okay, and intercept will be given by y bar minus m into x bar, okay. So that is another method, or that is actually the main method, or you can also solve this by this method, but for this you have to memorize this equation, this two equation, okay. So that is how you solve the problem. So is it clear to all of you? Yeah, clear, right? Okay, so any doubt regarding today's class?
So with respect to these equations and all, I just want to understand how it is relatable for image related problem statements.
Image related problems, see, line fitting means if you are given a pattern, okay, so like a circular pattern or a line type of pattern, so for that you have to fit a line, right? And how you can fit a line? You can only fit a line if you know this type of techniques, okay. Manually, if you know this type of technique, then only you can fit those lines, okay. So that is the use of line fitting, okay. Feature matching, feature detector, it is very useful because in a you can say in a image, key points are very essential to understand the image. So to know the key point, we just employ this feature detector, okay. And then we have feature descriptor. Feature descriptor, how feature descriptor come into play? Feature descriptor actually come into play because of this feature matching, okay. Feature matching means if we need to match two key points from one image to another image, so in that, or not only descriptor or the key point, but we need to know the local surrounding around this point, okay. So for that feature descriptor come into picture. Feature descriptor, what it does, it also understand the local area around the key points of the feature detector. Okay, so once we know the feature detector, once we know the feature descriptor, we can go for this feature mapping. For this feature mapping, we have different type of matching criteria, matching techniques, etc. And last we have line fitting. Line fitting I have already, line fitting or any pattern fitting. So line fitting we have discussed. So we have all this four equations, four techniques, and this four techniques. One is this two popular technique, least square, and this partial least square and total least square, and then RANSAC and this Hough transform. By this we can do the line fitting. Okay, and also let me show you. Yeah, so this is the folder. You can this folder, I hope everyone know this folder. Let me, yeah, so this folder, I have given you the codes. Okay, I have already given you all these codes, so you can see this fitting curve. Okay, and then you can see all this whatever we have discussed in the previous class, like shift, and Harris plus dog operator, Harris corner detector, etc. You can see. So this codes you can just open it. For example, let me open one detector like this Harris corner detector. Let me see. So this codes you can see, and you can see how we can apply this codes to the real image. Whatever we are learning, we have this application in this computer vision. Okay, so yeah, so this is the Harris corner detector. Detector means key point, right? So Harris corner detector, you can see this is the grayscale image. This is the grayscale image, and this is the Harris response value, or the F value that we have learned in the previous class. And this is the detected corner from the F value, and corner marked on the image. So that we have done from this Harris corner detector. Okay. Similarly, I have given code for all this. Let's open another one to just, it will take a bit of time. It is visible, right, this code?
Yes.
Yeah, so here I have done feature matching, so you can just see these are the different feature matching technique, like shift feature matching or feature matching, and one more Jake also I have given you. So you can see this feature matching, how we have done, we are doing it. Okay, so this you can see. So similar things you can do in the image processing. Okay, so if you do not know the theory behind it, you cannot form this code. Actually now we have all this Python codes, and we have this library, so we can directly call the library, etc., and do these things. But actually it is always whenever you are learning this computer vision vision course, so it is always important to know the theory behind this course. Okay, so these are the theory behind the course that I am discussing. Okay, so by this I am ending the session for today. So I hope you all guys know this where this codes solution, etc., are available, right?
Yes.
Anyone who does not know, still does not know where the codes, etc., codes and all this presentation and solution, etc., are available? I hope everyone knows. And if you do not know, you just go to the SWAM portal. At the below of it, there will be something called problem solving session. Just open the session. You will get a spreadsheet. In that spreadsheet, you will get content of all the TA. My name is Ayan Paul. You can against my name, you will can get a folder. Okay, and then that is the content folder, and all the recording I will be providing after the class. Everything that we read, that we study and study or discuss, I am just recording a YouTube video, and that video I will be posting in my YouTube channel, and that link I will give it. Okay, so by this I am ending the session for today. We will meet on the next Friday, same time, 6 to 8. Okay, so bye everyone.
Sure. Thank you, sir. Bye.
Okay, welcome.